So, from yesterday, what is our definition of a function that we talked about yesterday?
I forgot.
Zoe?
When you like put a line over it, it can't touch it twice.
Okay, that's our vertical line test, which is good. That's what we use to determine whether something's a function, so that's good. Good. You want to remember our definition that we had yesterday? Not quite. Shana? For every input, there has to be one single output. So every input has to go to at least one spot. It has to have one specific spot it goes. It can't go to multiple spots. It can't go to nowhere. It has to have just one specific spot. All right. So based off that information, what are we thinking about this first one? Is this a function, yes or no?
Yes.
Yeah.
I'm hearing a lot of yeses, but also a couple no's. Why is it a function?
Because man.
Ashton?
Because never mind.
Where does 2 go?
2 gets added by 3 and it makes 5.
Where does 3 go?
3 gets it's not a function. Because you have to change it.
Well, does the function necessarily have to increase by the same amount every time?
No.
Not necessarily. They can have different rules. It doesn't necessarily have to be a line. A line means we're increasing by a specific amount every time, but it doesn't necessarily have to be the same rule for every number. It just means that every number has a specific spot it will end up. So where does 2 end up? Where does 3 end up? 7? 11? So does every number I said end up at a specific spot? So this is a function. Even though they're all ending up at the same location, that's okay, but this is still a function. What about the second one?
Yes.
Yes. Just as Zoe said, we can do the vertical line test. And we can take our line, and as we go through, we'll never touch any spot twice. Even though it gets steeper and steeper and steeper, we get closer to it, but we'll still only touch every spot once. Okay. What about that last one? What was that, Riley?
5 going to the 2 and 9.
Because 5 is mapped to 2 and 9 as an output. It has 2 outputs, which makes it not a function because every input can only have one specific output. And so that makes our last one not a function. Are we okay with this from yesterday? Determining what is a function or what isn't a function? Okay. Once again, our skill quiz over this stuff is going to be Friday, like always, Friday assessment. So identifying whether something is a function or is not a function will show up on there. And then we'll talk about notation and evaluating functions today. Any questions before we get started? All right. So typically when we write lines, we write them in that slope-intercept form, that y equals mx plus b. And I know we just talked specifically with what actions point, but a function doesn't necessarily have to always be a line. Just like this first one, if you were to graph these points, it's not going to make a line. If you were to graph this, it's obviously like a curve, and we call that an exponential graph. So not every function is a line, but we're going to focus on specifically linear functions to start off with. But typically when we write an equation of a line, we write it in that y equals mx plus b. We have our output, we have our slope, our input, and our y-intercept. Are we okay with this? Our slope-intercept form? So, but when we have equations that we consider functions, we have a special notation of writing them. We try to make them a little bit more prominent, a little bit more noticeable. And so mathematicians have formed this thing called function notation. And so when we have an equation that's a function, we use a special representation called function notation to write it. And basically, it looks very similar. The only thing that's different is instead of using y equals something, we're now going to have this thing where it's going to be like f parenthesis x. And that's going to be our function notation. And you might be thinking like, why are we just adding in extra letters in there? We just need one variable. We don't need all these extra letters. And basically, this function notation is just it's the exact same thing. That y equals and f of x equals, they mean the exact same thing. Both of these just mean output. So just as the y always represents the output of a function, or the output of a line, or the output of an answer, f of x is the exact same thing. It's just going to mean the output. And we pronounce that as the f parentheses x. We read that as f of x. Welcome, Callie. Thank you. Let me pause this really quick. Okay, so once again, function notation is just a special way of writing these equations. We're just forgetting that y equals, and we're turning it into f of x equals. It means the exact same thing. There's nothing different, just besides what we're writing down. And so that letter f, that's gonna be the name of our function. It doesn't always have to be the letter f. You can use the letter t, the letter q, the letter s, whatever letter you want to throw in there. It really doesn't matter. Typically, f is your common one, just because like, f is for function. And then once again, x. So f of x is going to be your output. That's your dependent variable. Your x, once again, like always in the previous ones or any other equation we've ever worked with, that's going to be your independent variable, whatever you're substituting in. Are we okay with this? So really, the only thing that's changing is instead of having a y equals, we're just writing f of x equals. That's the only thing changing with this function notation. Okay. So when we write function notation, typically what you're doing is you're evaluating functions. So you'll be given a function or you'll create a function and you need to evaluate it when x equals something. And this is the exact same thing as if we were to solve an equation. If we were to plug in x for something and solve for an equation, solve for y, it's the exact same thing. We just have a little different notation of how we write. So when we evaluate a function, let's say we're evaluating the function g of x equals 4x plus 3, and we're going to say x equals 6. So we have our g of x equals 4x plus 3, just like what we said. So when we said x equals 6, we're just going to substitute that x, or we're going to substitute that 6 in for x, just like we would with any other equation. So it's the exact same thing as if you were to plug 6 in for x. But the thing is, we're going to plug 6 in for every x. And so we're going to have g of 6 here now. And really what this means, this is the same thing as y still. This g of 6, that still means y, as if it was any other function or any other equation. This just means the output of our function g when you input 6. So when you turn x into 6, this is what your answer is going to be. And so we put 6 in for our x. 4 times 6 is 24, plus 3 is 27. So what this is saying is, when you have the function g and you plug in 6, 27 is your answer. And that's sort of the math language behind this function notation. And it is a little confusing at first, and a little confusing on like why do we need to have function notation. But it does help rather than having y equals 27 or y, because y equals 27 only when x equals 6. It's harder to know when is y equal to 27. Yeah. So what do you want to do in your future?
I don't know.
All right. So if you want to go into a science field, if you want to go into a statistical field, if you want to go into even an agricultural field, if you want to go into aeronautics, those like algebra is probably the most common mathematics besides, well, statistics is based off of algebra, but algebra is the most common mathematics I could see anywhere. And so you might not be writing specifically f of x equals something, and you might not be specifically using function notation, but you will be using algebra in your future. I can guarantee that. And even if you do just want to, I don't know, become a writer or something and not have to worry about math or at all, you will. The process of learning this new thing is stretching your brain, is making you think harder, is making you become a better thinker and a better student, which is overall improving you as a society or a citizen of society in general. So even if this piece might not help you, learning the mathematics will always help you. I can promise you that. Even if it is confusing and boring at the moment. I'm sorry. We're okay with that? I'll take that as a yes. All right, so we're going to practice evaluating some functions. So typically on your state test, if you're ever told to evaluate a function, they're probably going to give you a situation. So let's say that the function W of x, once again, it's not always F, it can be whatever letter you want to throw in there. If you want to make it your first letter, your first name or something, go for it. It doesn't matter. W of x equals 250 times x. So that represents the number of words, so the number of words, once again, that's your output, your W of x, that a fifth grader can read in X number of minutes. So how many words could this fifth grader read in 8 minutes? So this is just an exact same problem we would have done before. If you were just replace this as y equals 250x, how many words can this person read in 8 number of minutes? You would solve it the exact same way. So nothing's really changing in that fact. The only thing that's changing is just how we write it. So we're going to write it W of x equals 250x. And we're told we're plugging 8 minutes. In X number of minutes, we're changing x to 8. So our output is going to be W of 8. So we're changing x to 8, so we'll change our x to 8. And that means 250 times 8. Once again, we substitute all those x's with our 8. What's 250 times 8? Someone's got this. What's 250 times 4? So 250 times 4 is 1,000. If we double that, 2,000. And so in 8 minutes, this fifth grader can read 2,000 words. That seems like a lot of words. But this is how you would write this function notation. Are we okay with this? Thumbs up, thumbs down. Yes, no? Okay. So let's look at another example. So we have Duncan here, and Duncan discovered a function that represents the average profit, G of X, that's your output, he can make from mining Bitcoin on his computer, where X is the number of hours spent mining his Bitcoin. So he has this function here, G of X equals 8X minus 14. That's his function he learned. He wants to figure out how much money he would make after 8 hours of mining, or after 24 hours of mining. So see if you can write the function notation, solve this problem, see how much money you would make, but make sure you're using that function notation. Take a moment, see. Okay, so let's talk about this. So, what do we do to solve this problem? How do we start off? What do we write first? Someone help me out. What was that?
The whole thing again.
So we write the thing again. So G of X equals 8X minus 14. So that's my problem. Good. Okay. Where do I go from here?
Put 8
Replace my X's with 8. Okay. So that means G of 8 equals 8 times 8 minus 14. Okay. What now? What's 8 times 8? 64. Minus 14. What does that leave me with? So G of 8 equals 50. So my function, when I input 8, equals 50. So that would be the amount of money. Good. We can do the exact same thing for 24. So if I put 24 in for this, I get 8 times 24. What's 8 times 24?
Okay.
So the second problem is because how much do you get after 8 hours? And then there's a second question to it. How much do you get after 24? So it's the same problem, using that same function. Just rather than plugging in 8, we decided to plug in 24 hours into our function. It's just 2 separate problems using the same function. All right, so 8 times 24 gives us 192. 192 minus 14, what does that end us up with, Joey?
178.
178, thank you. And so the only thing changing, once again, with function notation is just how we're writing the problem. Just rather than having y equals x, or y equals 8 times 8 minus 14, y equals 64 minus 14, y equals, we're having that function notation to help us sort of denote what the point is. Are we okay with this? Okay. So I have a little bit of practice for you.
Can I have this? Excuse me?
Yes, you can put that way. So we have a couple problems on the board. There are different functions. So for each of these functions, I kept it simple, and you're just plugging in -2. So you're just going to use the same input for each of them. Would you like to do one together, or would you like to do...
No.
Okay.
Not yet.
All right, we'll do the first one together.
LOL.
I'm gonna actually copy it onto another board.
Whoa. That's like plagiarism.
Whoa, that's plagiarism. Plagiarism, oh crap.
Okay, so we have our first problem. We have f of x equals 5x squared plus 3x minus 2. So this is our function. We're plugging in -2 into our function. That's going to be our x. So once again, I'm just going to replace all my x's with -2. So I replaced all my x's with -2. From here, our problem is really just order of operations. So what comes first? Parentheses. So the parentheses are really just sort of to denote that these two are being multiplied by each other. So if I just put a little dot in there, it's the same thing. Because there's nothing really happening inside the parentheses. It's just a number already. What would happen after that, though? Exponent. So what am I going to do? So -2 squared. What's -2 squared? So a -2 times a -2 will give me a positive 4. Anytime you square a number, we will always end up with a positive. Okay? What comes next? I got my exponents. What's after exponents? Multiplication. Do I have any multiplication?
Yeah, 5 times 4.
5 times 4. What's 5 times 4?
20.
Okay, do I have any other multiplication? 3 times -2, what would that give me? Make that a -6. And then -2.
And then we just go on.
So I have 20 minus 6 minus 2. What is all this going to tally up to? 12. And that would be the answer to my function.
Hey, we did it! 2 days.
Good job.